Okay. Um, hello. So yeah, this talk is about cats. No, I'm joking. It's about history of programming languages. So history of programming languages is a thing that, it's one of those things that as you're going as a software developer, you kind of first you're just doing your thing because you're learning to program and whatever, and then you are learning more, and then you start assuming things that you know, right? For example, I started programming in Pascal, and then I did Delphi, and then I did C sharp. And when people told me about Anders, it's like, oh yeah, of course, he was working on Delphi, and it's like, and then I started thinking that other people should know the stuff that I know because they were also programmers. But it turns out that we're all different and we have different backgrounds, and learning about other people's backgrounds is kind of cool. So I kind of thought, well, that's something that you kind of have to do with intention. So you have to learn that, right? And then I thought, well, why would I spend time, my precious time, instead of writing code or doing something like playing with cats? Why would I just spend it writing boring, history books? And well, the only way to find out is to do it, right? Um, so that's why I'm here. And I kind of do it with a retrospection on me because I also assume that our people should know. So I hope that you're interested in what I got to say. So my name is Andrea Magnorsky, and I work in a company called Workday. It's funny because this is an enterprise company, but they have their own language too, which is kind of cool. So they have a slightly more, enterprise, but they have an interesting programming language, which is absolutely not what I'm going to talk about today, but I thought it was kind of cool to mention. So the thing about history is that there is all this, like each one of you has a vision of what is going on. And some of you are picking up on, some stuff, I'm picking up on some other stuff. History is the same, and there's a lot of things that contradict each other. So maybe a few of the things that I'm going to say contradict your knowledge and understanding of what happened, and that's okay. Also, I couldn't name all your favorite languages or even the important ones. I just chose some. So, get on with it. Like. And so yeah, where am I going to start? I'm sure some of you might be wondering, what am I going to show first? So we'll start here, right? Okay. So I'm going to start with David Hilbert because, well, in and around, this guy had like a lot of background on mathematics and logic. Um, but the thing is, like, he was trying to come up with the like foundations of mathematics. Right? He had a really cool social circle, namely Emmy Noether, Alonzo Church, Haskell Curry, like really like calm people that didn't know what they were doing, of course, and I'm being sarcastic. And like his assistant was John Voight Neumann, and like the list keeps going. This is like ridiculous. All these people were literally in the same place, kind of like here today. We feel good about that. Cool. So imagine someone like that. And at the same time, there was a philosophical movement by Emile Dubois Reynolds or something that they were going with, we do not know and we won't know. So imagine all these cool people going like, yeah, I want to learn all the stuff. And at the same time, some other group of people going like, it's okay. We just don't know. And we're fine with that. So the response that David Hilbert had to that was that, actually, you know what? We must know, and we will do it. And which is kind of very, from a philosophical impetus point of view, this was very, very cool. In and around the time he said this, he also started talking about a problem / question. And I'm going to totally kill the German language here and go with the Entscheidung problem, which I'm sure, sorry, German speakers, but basically this is the decision problem. And basically this is about trying to figure out if a logical statement terminates, if there is a yes/no answer to something. And that's a better explanation of what I just said. This was done in around 1928. In about 1931, Kurt Gödel said no. So Gödel is a logistician, probably with Aristotle and Frege, or whatever I don't know how to pronounce it. It's the same name as the other JVM language that is in Haskell. Top logistician people, so that's cool. So Kurt Gödel said no, but the thing is, like, we still needed to like devise what really was meant by a computation. Like, what is an algorithm, right? So to the rescue, our friend, Mr. Church, right? And to do that, he devised a formal system for expressing computation, and that was lambda calculus. Cool stuff, right? In and around the same time, and I'm being non-specific on purpose, our friend Alan Turing came to the rescue and created the Turing machine. And I really like this representation because it's kind of like what I imagine when I think of the definition, which is an abstract computational device that, you know, to kind of manage and kind of figure out the limitations of what can be computed, right? By the way, for every bit of stuff that I mentioned here, or paper that I mentioned here, there's resources at the end of the slides, and there's links, because I know people generally go like, oh, where did you get that, or whatever. So this is in and around 36, 37, Church, lambda calculus, and Turing machine, and Gödel actually had a lot of discussions, and they were kind of animated, and one of the side effects of that was the Church-Turing thesis, which basically meant that both the lambda calculus and the Turing machine were equivalent. So meaning those two things are, hey, this actually makes sense, and they're two different things, but they do the same thing, which is really, really cool. We're talking about the year 36, 37, and they were in Germany, which is a bad spot, because there was Nazis, and, you know, was generally unhappy, so people had to go. And this is kind of like the least weird / sad image I could come up with to talk about that. But what that meant is that I'm just going to avoid all that time and just say that during that time there was a lot of development in hardware, right? And Turing was involved, as all of us know, in some of that. And you can go to the Bletchley Park Museum in the UK for at least a couple of months more, as far as I know. So we know that he's there, and then we come to talk about Grace Hopper, right? So I'm going really fast on purpose because, loads of history and stuff, but you can feel free to like laugh and also like fall asleep if this is really boring. So anyway, we're talking about Grace Hopper, and we're talking about more or less the years 43, 49. She was involved in a lot of early machine development, and she was writing a lot of machine code to the point where she realized that maybe it was a good plan to stop writing this really easy to make mistakes stuff and abstract a little bit. And so she came up with the first compiler called A0. A couple of years later, like not too much after, not so much long after, she came up with an actual programming language called Flowmatic. This is the year 54, 55. This wasn't the first programming language, but it was just very, very close. In and around, just for reference, this is kind of what it looked like, right? This is Flowmatic. I mean, even some of the beautiful Erlang syntax early on there, right? I know, Robert is not here, so it's okay. I know, sorry. So this is some little bits of Flowmatic, which brings me to John Backus, right? So we're talking about Backus, and this is a guy that one of the first things that he was doing was after graduating, he was working on calculating the position of the moon, which is a cool gig if you can get it. If anybody knows about that, totally interested. In and around, this is the person that in and around 1953 gave us speed coding, so just a little bit before Flowmatic. Then he kept working on that at IBM, and with a team of people, came up with Fortran. This is the same person that a couple of years later gave us the Bacchus-Naur form, and a very cool paper called Can Programming be Liberated from the von Neumann Style, which is seen as like an apology for writing Fortran, which it's kind of funny. But it's good. It's good that he wrote Fortran. He spent a lot of time actually trying to come up with this, but also it's good that he went and wrote this paper because he's like, hey, I learned from this stuff, which is cool. So for those of you that are wondering what Fortran programming looks like this. You actually had to do it in these sheets initially, and this is kind of what it looks like. There is stuff going on. There is, I don't really know. You can actually, there is some online things that you can go and check and actually write some Fortran, though not the first one. This brings me to, obviously, John McCarthy. Now, there's a lot of people that do Lisp here, and I have a lot of respect for this man. So you all that do a lot more Lisp than I do would probably know more about this stuff. So I'm just going to keep it light and say that, heads up. So this is the guy that came up with the term AI. And with Lisp, we got like garbage collection, time sharing, and Lisp processing, just incredibly data structures. This is the year 58. 1958 or 59. This is ridiculous. So with that, we go to Algol. Now, okay, that picture looks terrible there. It looks much better in my screen. But basically, it's a bunch of people sitting down. So this is the ACM committee saying, hey, people, let's all get together and actually, try to come up with a common language. And that was good because, McCarthy was there, John Bacchus was there, Peter Landing eventually joined. So the people that were involved in the languages that we were just talking about, COBOL, Fortran, Lisp, we're all in kind of one room, or at least talking to each other, right? And that meant good things. So, okay, now this is where I wish that I had better pictures. This is a graph from a paper called Programming Languages Past and Future by Jean E. Sammet. She wrote this paper in 1972, kind of, describing the 20 years of programming language history. And this is this graph I particularly like because you can't see it, but basically this is 1960. So this is like the languages that we just talked about and where they are. And it's like afterwards, it just went like completely crazy because languages started influencing each other and just things happen. So this is what people start learning from each other. And I'm going to make this emphasis on people all the time because it's a very obvious trend to me. So that's cool. And you can see that a lot of that influence comes from that Algol committee and the 58 and the 60 following, which is cool. So this is like the first part of the talk where I kind of talked about people in particular, but after this, it becomes impossible because it's just too many people. So now I will go through every decade, and I chose some languages, 4 or 5 languages each. We just described all of these languages. 3 of those languages are mostly imperative declarative languages. One of them is a functional language. As you can see, they're close in time, which is cool. And this is a Lisp. What does a Lisp look like? There's parentheses. The way you read this is slightly different to what you would be used to in our languages. But I know some people laugh about this and go like, oh, parentheses the worst. I think you kind of get used to it. It's fine. Like, it's fine, right? Also, this is supposed to be standard common Lisp, which is not the original Lisp, but again, I'm just trying to throw you in the water and von Neumannize it and say something like, there is no point in being precise about something that you don't know much about. And this is what I'm trying to do. I'm just trying to throw a bunch of stuff at you, and you're going to go like, okay, now I have a fuzzy idea of where things are, and I can go and dig deep if I want to. So this brings me to a really exciting decade, right? We got APL. Who loves APL? Come on, come on. Cool. You guys are cool. So, the three of you. Um, so, um, so APL is a really interesting language for a couple of reasons. But the first thing that they were trying to do is kind of say, well, we want simplicity. And the thing's like, well, simplicity kind of comes after complexity, really. You know, something is simple, maybe turns up there and it's simple, but generally, as Alan Perley says, like a Perlism is basically stuff first is complex and then you simplify it. So I think that we're going for something like this. So this is a language that you read from right to left and that looks a lot like mathematical formula. In fact, my view on this is that the only reason this language is not more popular is because they have that weird custom keyword. I think if they would have gone for a normal keyboard, they would have won. But that's my view, personal view and stuff. Then this is 1962. Then we have BASIC, and we're thinking about microcomputers, and they were trying to bring programming to everyone. I mean, does that sound familiar? Because it really resonates with something I saw in a newspaper yesterday. So then we come to, so APL is a functional language. BASIC is kind of imperative-y stuff. Logo, who programmed with the turtle? Cool. Come on. Come on. I grew up in Argentina, and we had Logo there. Okay. So I'm sure that most of you, if you didn't use the turtle, you kind of didn't want to. And it's a great educational tool, and it actually had great success. I think it got to Argentina now. Also a functional language, and in fact a multi-paradigm language. Then you have Pascal, and this is one of those languages that came straight out of the ALGOL 68 committee, so ALGOL kept going as a thing that people met up and talked about. This is Nicholas Wirth programming language. He's kind of mostly based in Switzerland. Now, if you ever are looking for papers to read, just pick any that he wrote, and you're gonna be in for a treat. But anyway, the creator of Pascal, my first language, so a lot of time for that. So I'm sure you know, since there was only 3 people that liked APL, or that loved APL, this is what a program that does APL looks like. Now, remember they were talking about simplicity and elegance, and then the first time I looked at this, I went like, what? I mean, it's simple. I just have no idea what's going on. But so what this thing does is it finds primes, you know, up to a number. So if you have a number R, and you want to find, you know, all the primes that are below it, what you say is like, you know what I'm going to do? I'm going to create a vector. I'm going to drop the first item. Then I'm going to do this matrix multiplication. And then with this negation stuff, I'm going to drop everything that is not in the diagonal. And what's remaining, it's a prime. Now, I know. The thing's like, when you follow it, after you follow it the first time, it starts actually making sense. And I found myself going like, this is really simple and elegant. And I'm not joking. I don't know if I would do it for reals all the time, but it does something very, very nice to your brain. So I recommend you try it. Yeah, and in a good way. Come on, I know what you're thinking. So anyway, that kind of gives you an idea. I've been trying to show the strangest languages as a way to say, hey, look at this cool stuff that happened in the past. So then you have the 70s. Woo. Now, probably the most influential language that sadly is not used is Smalltalk. This is 1972. It's Alan Kay. It's written by Dan Ingalls. This is the beginning of OO. And one of the things I love about this is that it was a language influenced by something completely out of computing, and that is like cell and microbiology interactions and stuff. And that's really exciting. So also influenced by Simula and a dynamic language. So that's 1972. Then it comes to a family of language that I have a lot of interest in, and that's ML. This is where we see the first type functional language, which is very cool. And you should check it out if you haven't used an ML. I mean, who has used any ML, like, for example, OCaml, Standard ML, F#? Good people. The rest of you should totally check it out because it's amazing. Then we go to Prolog 1972, probably the most well-known like logic programming language, and it's declarative, like that's the distinctive thing. And then we have C, a language that, as far as I see, sorry, as far as I see, was kind of, it emerged from like, seriously, I need to like manage this as a system, and I need something that can touch the bare metal without crazy abstractions. Seriously, I need this. So this is Dennis Ritchie and Ken Thompson. We're going to talk about Ken Thompson a little bit later. So fringiest language. We're talking about declarative programming. What does that mean? Andrea, what are you talking about? That's me. So you kind of say, I'm going to give a relation between things. I'm going to give another relation between these other things, and then you ask Prolog, hey, what's going on? Generally, Prolog replying like false. But of course, sometimes it replies yes, sometimes it crashes. But at least that's what happened to me. But it's still really fun to do. Mostly because I put, you put in stuff that doesn't work, and anyway, you get what I'm saying. It's still kind of cool to know, very different way to think about a problem and stuff like that, so that's cool. So we're in the 80s, when some of us were born, some of us might be born later. And we have 5 programming languages. I included one today. You get 0 points if you guess which one. So in 1996, Erlang was created. And the funny thing about this is that this is an interesting language because they were like, we need 0 downtime. We need to hot swap things. We need the thing to be like working all the time. And 3 crazy people, well, one more crazy than the other 2, created this beautiful, beautiful thing. Highly influenced by Prolog. In fact, a lot of the syntax is Prolog. Concurrent, functional, a lot of message passing. They implemented the actors without actually knowing what actors were, and they figured out later, oh, by the way, we discovered actors too. So that was cool. So that's Erlang. Then this is the only kind of domain-specific language that I talk about in this talk at all. That's SQL. This is basically a practical implementation of relational databases, and this is like Todd's theories from the 74 or whatever year he published that paper. This is like, hey, let's actually use this. 83. Then we have Miranda. Oh, Miranda. This could be fun. So this is one of the many languages that David Turner implemented. Very, very inspirational for Haskell. A lazy, purely functional programming languages that lack side effects and imperative language features. So, that's cool. Then we have C++, which is also influenced by Simula, kind of like Smalltalk was. And basically they went, okay, C, I like C, it's very cool. I need some classes, I need some strong typing, and other stuff. Basically, I need to grow this, I need to do more stuff. And that's pretty cool. The thing that I thought it was, oh, okay, I see a trend again following that thing of system programming languages doing something slightly strange. And one of the philosophy things that they have that I found about C++ is that they were like, we want to give the users advanced features, even if they can be misused. Literally, we don't care about safety, but we want to be able to do things. I want to get things done. I don't want this thing to get in my way. Finally, we have Perl. This is
postmodern language.
It's a postmodern language. I really liked what Larry said this morning about, hey, there's these languages that are kind of like fads. We've been here for a long time. And I thought that was really cool. And it kind of goes well with where I'm going with this, maybe. So again, because this is the strangest language that on that list, I think, this is an example of Erlang. Here is that syntax that I talked about, semicolon, semicolon, dot. Robert loves it when people highlight that. So what you do is you define a module, if you want to show something and make it available to something else, you say, this is my function, this is the arity of those functions, and then you pattern match if you want, you do your operations if you want. And I kind of think it's kind of self-explanatory, but at least if you've never seen Erlang, here's some. This is two functions, declare a module, boom, we're gone. So we get to the 90s. And in the 90s, there's like these three languages at the top, and the other languages, right? Oh, sorry. Haskell is a standardized language and committee-based. This is the language where we see type classes the first time, which is really cool, and a bunch of really, really nice features. Now, the three languages at the top are kind of standardized or driven by a group of people. The languages at the bottom, they're driven by companies, and not like teeny tiny companies. They're driven by big companies trying to do a lot of stuff. And that is the trend that I kind of detect. If you put more languages there, you can add Visual Fox Pro and other stuff that was there at the time. And that's very cool. I kind of think that in this room it's a bit not necessary to go on details about what these languages do, slightly closer or different. What I do see a trend there as imperative or some features of OO, trying to GUIize yourself and stuff like that, be able to write GUIs or some sort of UI interface with people and whatever. Since none of those languages are fringy, I decided to go with the most popular one. And I even included a bug, just for your enjoyment. You're welcome. And now, we're getting close to today, right? And we have the noughties, right? So we have all these languages that are multi-paradigm in general, that are they have some functional aspects to it, that are, literally saying the lunch is really over, and our designers have realized, and we're trying to do something about it, which is cool. Then we have something like D, which is a system. It's basically someone saying, well, C++ is not enough, and it creating something pretty amazing, something that allows you to do some very, very cool meta-programming stuff. And then you have Go, which I'm sorry, but I really know nothing about. I honestly don't. It's not. I didn't do it on purpose. It's a language by Google. I know you can do very cool stuff about deploying to stuff, but and there's a cool programming, a cool new programming language called Odin. Now that I'm interested in that. That's cool. So because this is the weirdest of them all, I decided to show some D, right? So you can do type classes in D. That's cool. Well, I guess it's probably just close to type classes. So that's really nice. This is the weird bit that you want to look at if you're looking at. This is how the magic happens, I guess. The rest is pretty C-like. So that's really nice. I'm just going to leave it there. Totally, you can go see it later. Because actually, we're close in time. We're in this decade, right? Now, 4 of these 5 languages are driven by a benevolent dictator. Some more benevolent than others. And then you have Rust, which is a really nice systems language driven by Mozilla. And so towards throughout the decades that we've seen like there's always one system programming language. There's something functional about stuff, a little bit more or less. But here, we see a very, very, and maybe it's because the decade is not over. Maybe we'll come back to OO magically in the next 3 years. Surprise! Hopefully not. Did I say that out loud? Oh, God. But what we see in all these languages is there's really nice algebraic data types, pattern matching, and all the languages, all the stuff that actually, you can get stuff done, which is really, really, really nice. Or at least I think so. So we're in this decade. So of course I have to show Idris, right? So Idris said, what? It's okay. It's okay. I know it's very exciting. Just calm down. So Idris is a dependently typed programming language. What you can do is basically do more with types in the way of, you can say, I'm going to prove stuff. In fact, I don't know if that's going to work, but you can say stuff like, I want this vector to be this way, and in the words of Edwin Brady, it's a Pacman complete programming languages. As in, you can create a Pacman. Nobody cares about Turing complete. This is what he said, so you go talk to him. It's written in Haskell, and you should go try it out, and or get the book that he wrote about it, which is really good. And there is really good tutorial for all these languages. You get a lot of really good talks, at least about getting started, which is really nice. So you might be wondering, where am I going with all of this? Because we had part one where I got to this is how it all started. Then I brought you through all these languages, through all the decades. And now I'm going to try to kind of round it up, which is hard. So this is my beautiful art. Sorry, data science that I did. It's really good. So what I've done here is basically went through all the languages and said, down here in this yellowy area, there's like imperative OO stuff. In the middle, you have functionally stuff. And in the very top, darker, you have logically light stuff. Again, completely inaccurate, and slightly on purpose, slightly because apparently I don't know how to draw. But also, I was trying to find trends. What is going on? And of course, if I would have done this a little bit more precisely, we would have found this like, wow. I should have put how many developers we thought we had on each of the languages, because that would have given us a lot more data, right? And you can see this clear trend of people and languages going more towards here. You can also see the trend of, okay, maybe some of these languages were more researchy. You can start thinking about this a little bit more. I'd love to think about this more. I did this badly because I thought, I can't see this thing that I see in my brain with all this data. So if you can think of better ways to illustrate this, I'm totally welcoming feedback and or help. So that's one view. You have this idea of paradigms over time and how it's been going. Another view of this is something like this. This is from Concept, Techniques, and something else of Computer Science. It's a well-known book with the Sagrada Familia on the cover. It's like 13 euros on Amazon. I shouldn't say that, right? Okay, anyway. It's really good if you want to learn about programming paradigms. And it gives you this overview, right? So in here, you have logic programming languages, and you can't read this, but it says prologue there, I swear. And then in here, you have imperative OO languages. And in between, you have functional with some different flavors of lazy, non-lazy. And I thought, you know what? That's great. Still, I feel like I'm losing some information on this, right? So that's kind of what I see there. This is still really useful, and it's really good to reason about, because what's happening here is that some languages that turn up here, like Okamo, turn up somewhere else as well. So you start learning about what does it really mean for a language to be multi-paradigm? Like, what are the side effects of that? For real, which is nice. And then I got this, right? So this is as precise. Oh, God. Oh, yeah, I have this other one. Wait. No, go up. Oh, there we go. This is as precise as Wikipedia data gets, but I can't click on it because that would be really useful. So, whoa, that's great. I really love this. This is a great user experience. Okay, we're going to imagine what happens here, right? So this is a graph generated by Wikipedia data. It goes and kind of goes over all the data about languages and finds what was influenced by and what influenced it. And you can click on one. So imagine I clicked on it, right? And a bunch of things connect. And I told you what was influenced by, and you also know which language, your favorite language influenced stuff. And the funny thing is that you see the bigger circles are obviously the most influential and the least influential. And that means, I kind of started thinking about this talk, when I was thinking about, well, why programming languages look as they do today. And obviously, they influence, the syntactical and semantical influences are obviously significant. And this graph kind of shows that a little bit. So it's nice to click about when you can. It's really amazing when you can. You should totally click on things whenever you can. Wait, no, I won't be able to do that. This was working 5 seconds before the talk. Anyway, so we have 3 views of these programming languages, none of which are extremely conclusive. So I was trying to, okay, let's herd these cats, right? So this is all these ideas that are slightly, like, not very, coherent. Maybe they shouldn't be coherent. Maybe that's what we're supposed to do. So I see a growing trend towards attention to tooling and developer productivity. But you know what? I'm lying. I think that's been there all along. It's just that not always, language designers could actually pay as much attention. Basically, the funding wasn't there. They were like, oh, just do it. And maybe that was the thing. Maybe it wasn't. I do remember Don Syme actually talking about this in CodeMesh last year, saying I should have paid more attention to tooling, or I wanted to pay more attention to tooling. You see, I'm going that way, etc., etc. But this is a concern that is real. Then this one is one that actually we're talking here with some people yesterday. And this is the tension between good languages, and I'm doing quotes, please note the quotes and stop throwing things at me, just in case you were thinking about it, and getting stuff done. I can see an obvious tension, and actually, I kind of want to reward it as a tension between languages that are inspired by the machine and what the machine does in a kind of natural way, and languages that are inspired by literally everything else. They are more abstract, and that have these design ideas. So, that's a thing that is there. I don't know how to express it better, but I think there's something there that I'd love to keep thinking about. Finally, is people and communities developing languages. I see more on that, definitely the trend, and that's really, really cool. And when you come to people, as I mentioned a bunch of times before, people are now really the creators of the languages. The languages are tools for our brains as developers, right? So if the tools shape our thinking, then that means that programmers, program languages designers are actually philosophers, kind of like Hilbert was, which is nice, I think. So with that, I'm going to say thank you, and that's it for me. Cheers. Yeah, do you want questions?
So what will we do in the 20s?
Sorry?
What will we do in the 20s, I mean the 2020s?
I really hope that they invent a language for cats, because that would be amazing, and see what our lords, masters represent. Singularity? I don't know. I have no clue. I have no idea.
Actually, there's already a lot of code for cats.
Yeah, I know. Of course I know what this is.
My question, though, your lists of languages from each decade, were they sorted in any way?
They were, so I selected them based on, I did want to show some level of strangeness. But the way they were sorted were according to what I liked, because I thought, this is going to be subjective any way I do it, so I might as well do it the way I like it.
Because I noted in the 90s, Haskell was at the top and JavaScript was at the bottom. That sounded sort of political.
That was totally not intentional at all. Yeah, that was completely accidental. Also, maybe they're kind of like, maybe like, there's some connection there. I mean, you do pure script, so you know what I'm talking about.
Maybe that's your good language, getting things done in a particular way.
Well, it depends on what you mean by that. Anything else?
Any other questions?
Yeah, it seems like we have a comeback Clojure makes Scheme and Lisp doing comeback, and the Node brings back JavaScript from the dead. Or so do you see any more old stuff coming back?
Absolutely. I don't think things die. I just think they go to sleep for a bit. So yeah, and it's great to see ideas being rehashed, because that means that someone at some point hopefully thought about some stuff, and some of the ideas were retained, and we're not reinventing the wheel totally. So yeah, I hope so, and I hope there's more. Yeah.
Okay, let's thank the speaker again.
Cheers. He was trying to come up with the foundations of mathematics. Right? He had a really cool social circle, namely Emmy Noether, Alonso Church, Haskell Curry. Really calm people that didn't know what they were doing, of course, and I'm being sarcastic. And his assistant was John Voight Neumann, and the list keeps going. This is ridiculous. All these people were literally in the same place, kind of like here today. We feel good about that. Cool. So imagine someone like that, and at the same time there was a philosophical movement by Emile Dubois Reynolds or something that they were going with. We do not know, and we won't know. So imagine all these cool people going yeah, I want to learn all the stuff. And when people told me about Anders, it's oh yeah, of course, he was working on Delphi, and it's and then I started thinking that other people should know the stuff that I know, because they were also programmers. But it turns out that we're all different, and we have different backgrounds, and learning about other people's backgrounds is kind of cool. So I kind of thought, well, that's something that you kind of have to do with intention. So you have to learn that, right? And then I thought, well, why would I spend time, my precious time, instead of writing code or doing something like playing with cats? Why would I just spend it writing boring, history books? And well, the only way to find out is to do it, right? So. Whenever you're ready, I'm ready.
Okay, take us away.
Okay. Hello. So yeah, this talk is about cats. No, I'm joking. It's about history of programming languages. So history of programming languages is a thing that it's one of those things that as you're going as a software developer, you kind of first you're just doing your thing because you're learning to program and whatever, and then you are learning more, and then you start assuming things that you know, right? For example, I started programming in Pascal, and then I did Delphi, and then I did C#. I'm picking up some more stuff. History is the same, and there's a lot of things that contradict each other. So maybe a few of the things that I'm going to say contradict your knowledge and understanding of what happened, and that's okay. Also, I couldn't name all your favorite languages or even the important ones. I just chose some. So, get on with it. And so yeah, where am I going to start? I'm sure some of you might be wondering, what am I going to show first? So we'll start here, right? Okay. So I'm going to start with David Hilbert, because, well, in and around, this guy had a lot of background on mathematics and logic. But the thing is, that's why I'm here. And I kind of do it with a retrospection on me, because I also assume that our people should know. So I hope that you're interested in what I got to say. So my name is Andrea Magnorsky, and I work in a company called Workday. It's funny, because this is an enterprise company, but they have their own language too, which is kind of cool. So they have a slightly more enterprise, but they have an interesting programming language, which is absolutely not what I'm going to talk about today, but I thought it was kind of cool to mention. So the thing about history is that there is all this, each one of you has a vision of what is going on. And some of you are picking up on, some stuff, some are